The key novelty of our approach is simulating a soccer match a few seconds into the future. Let's take the following situation. We're interested in the optimal move for the left winger. At this point, the player performs what's often called a disruptive run. He runs as if he wants to receive the ball, but at the same time, he's actually opening up space for the left back. Our first step is to use a passing model. Green area shows the space that's been opened up and where the left back can receive a pass. The red area is controlled by the defence. Passing models have been increasingly used in the analysis of soccer. The novelty of our paper is to look at the decision making directly after the disruptive run is made. This picture shows the areas of the pitch controlled by the two teams just as the pass is about to be made. Our model assumes that the left winger can see 2 seconds into the future to when the pass has arrived at its target. The output of that simulation is shown in this picture. What is most striking about the simulation's prediction is that it requires the left winger to stop and to occupy a space just behind the defence. Returning now to the video, we see that this is almost exactly what happens. If we compare what happens in reality to what happens in the simulation, we get a very close match. This time we're interested in how the team in green, Hammarby, get the ball back from the team in yellow, Häcken. We can use pitch control to see how Hammarby have controlled areas of the pitch. Green is area controlled by Hammarby, yellow is area controlled by Häcken. We can compare the optimal positions, again by assuming that every player can see 2 seconds into the future, with the actual positions. In this case, the actual positions are given by the shaded dots with the arrows on, and the optimal positions are given by the solid dots. In pressing, the Hammarby players are almost optimally positioned, according to the model. The outcome of the model doesn't always agree with what the players' actions were. In fact, when it doesn't agree, it's the most useful. Here we've labelled the roles of each of the players in this situation. When we simulate the model, again assuming that the players can see a few seconds into the future, in this case, number 22 made a run into the penalty area. What the model said that he should have done was perform a supporting run to come up behind the striker who had the ball. The simulation allows the coaches to have a more structured discussion with the players after the match about how they could have acted in different situations.